Hello everyone. Welcome to La Silla Observatory virtual tour guide for today. Welcome to everyone from everywhere in the world. My name is Hernan Julio, and I'm a journalist specialized in astronomy. And I welcome to this tour. I hope you enjoy and um, be with us until the end. Well, I want to introduce you to our colleague Felipe Zurita. Hello, Felipe. How are you?
Hello, Don Hernan, Mr. Hernan, and hello, everyone. I see. I'm Felipe Zurita. I'm licensed in astronomy, and today, as the producer, I'm excited to bring you a side look at cutting-edge projects and show you the entire La Silla Observatory. Right, Hernan? Today is
All
the La
right.
Silla.
Yes. Well, thank you very much, Felipe. We want to welcome everyone who is in connected today. We want to encourage you to please send your greetings through the chat, the Facebook chat or the Facebook chat. Please say hello and let us know where you are from. And also let us know your questions. Okay, we will be pleased to answer all your questions. We say hello to Carlos Kalim from Brazil, Sway Graven from Amsterdam, Snowy, hello from Denmark, Frankster Nowacek. He say hello also. So, hi everyone, and please, if you have any comment, any question, we will very pleased to answer to you. Well, we will start right away because we have just 1 hour to get to know the La Silla Observatory, one of the most productive observatory of ESO observatories in Chile. But let's say who is ESO? ESO is the European Southern Observatory. It's an international organization with 16 countries that you can see in your screen. This is the 16 country part of ESO. Also, we have a strategic partner, which is Australia, and of course Chile, which is the host country. In Chile, in the northern part of Chile, is where we have all the telescope in Chile. This organization already has 60 years in Chile. The organization itself started in 1962 with only 5 countries, and today, as you can see, are 16 countries. And they arrived in Chile in 1963. So just last year, we celebrate our 60th anniversary. That's a lot of time. Okay, so want to welcome you to this tour and let you know how all started, and that was in La Silla. Let's see in the next screen. You can see the Chile map in the center, and to the right says La Silla Observatory. It says there is a picture of this ISO 3.6-meter telescope and the NTT, the two main telescopes in La Silla Observatory. La Silla Observatory was inaugurated in 1969 and was the first observatory, ISO observatory in Chile. As you can see in the map, is in the little northern part of the map, northern south part of the map, actually from Coquimbo regions, is La Silla. We're about 500 kilometers from Santiago. So if you want to visit us, you can come, take a plane to Santiago, land in Santiago, and then go by car or by plane to La Serena city. La Serena city is the main city close to La Silla Observatory. From there, you will have to drive only 1.5 hours to get to the observatories. Remember that we are open. We have open doors every Saturday for visits at 10 o'clock in the morning and 2 p.m. in the afternoon. So we just want to welcome you, and also we will be so pleased to have you here in presence in La Silla Observatory. But this is not the only observatory. 60 years has happened already in the world, and of course also in ESO. And ESO today has another observatory. You can see it in the northern part of the country, in Antofagasta region. We have Paranal Observatory. It's the first picture to the left. It says Paranal and the VLT and the VLTI. Today, Paranal are four 8.2-meter telescopes, okay, and has an interferometry. That means that we can use the four telescope together to point to one star and make a big mirror, virtual mirror of 130 meters. Okay, Paranal is one of the most advanced telescope in the world right now, and you can also come visit every Saturday at 10 o'clock and 2 p.m. in the afternoon. And also in Paranal Observatory, we have two more telescope, more we call mapping telescope or survey telescope with the VST and VISTA. And there is another telescope a little bit to the right between Paranal and the Chilean map in the center is the ELT, the extremely large telescope. The extremely large telescope will be one of the will be the most biggest telescope in the world with 39.3 meters in diameter. The main mirror has five mirrors, and the biggest one is the 39.3, the main mirror. It's a segment mirror. Of course, we cannot build a 39 meter diameter mirror, but we can do with segment mirrors. However, this is already under construction, and it's already 50% of the construction is ready. So we hope to have ready the ELT for the year 2029. And also in the end, at the bottom left, excuse me, is you can see the CTA South. The CTA, this is the Cherenkov telescope array, is going to be 99 telescope of 24, 12, 5, and 4 meters. And these are special telescopes that are going to be built very close to where Paranal and Almazone is in the northern part of Chile in Antofagasta region, 120 kilometers south from Antofagasta. You can also come fly from Santiago, go to Antofagasta, and then drive south, a little south for 1.5 hours, and you will reach the BLT, the contraction of the ELT, and the future CTA. And also to your right, to extreme right, you will have Chajnantor, ALMA, the Atacama Large Millimetric Array, the most biggest radio telescope in the world at 5,050 meters above the sea. In this telescope, in ALMA organization, ESO is a partner, is one of the most important partners of ALMA, and their strategies partner also in ALMA. And we have also APEX. APEX is ESO. It's just one antenna, APEX, the Atacama Pathfinder experiment. And ALMA is also in the Changnan Tor Plateau. It's one antenna of 12 kilometers in diameter. ALMA is 66 antennas, okay? That means, and also do interferometry. That means that you can put all the antennas together, pointed to the same star, and you will have, in the extension mode of ALMA Observatory, a parabol of 16 kilometers. Wow. Well, those are the telescopes that ESO has in Chile, is operated in Chile. Let's see if we can give you an idea of flying. We will in the next video, we're going to fly from Europe, from the European continent. You can see there the countries that are part of ESO, and we were going to fly from Europe over the Atlantic Ocean to go to South America. Okay, the European and also the Americans in the 60s, they start to look for a place in the southern hemisphere where to build this telescope, because in those times they only have big telescope in the northern hemisphere, and they need to have a big telescope in the southern hemispheres too, in order to see the celestial sky from the southern hemisphere. And guess what? They found Chile. Why? Because we have the Atacama Desert. Okay, the Atacama Desert is the driest desert in the world. Okay, and and we have about 300 clear nights per year. That means that it's the best astronomical site in the world. Here we are. We go right the way to the Atacama Desert, in the southern part of the Atacama Desert, where La Silla Observatory is. There you have La Silla Observatory with 14 domes, and most of them today, as you will see there, automatic. Let's take a look to them. That's the 5-meter Danish dome. Then we have the Danish 1.54-meter dome is already working, is still doing science today. We have these small ones, ECTA. They are a small telescope looking, robotic telescope looking for planets around other stars. The 2.2-meter Max Planck Institute telescope for today. We have the 1-meter Schmidt camera. Okay, and of course in the last part of the upper part of the mountain we have the NTT, the New Technology Telescope, the CES, which used to be the biggest radio telescope in the southern hemisphere. Today is out of order. And here we have, of course, the Swiss 1.2 meter, the Tarot telescope, small rapid eye movement telescope, and the visitor center, and the 3.6-meter telescope, the biggest telescope in La Silla, which is the classic telescope today. We're going to visit today two of the most important telescopes. Okay, for that we're going to use our 360 degrees tour. Um, Here we are already in La Silla. We are going to have a view of La Silla. We're looking to the east now, to the mountains, to the Andes Mountains. La Silla is really a small city, yeah, built in the Andes Mountains. Here we have the radio telescope. This radio telescope is not working anymore. Everybody's working at Alma right now. And here now we're looking to the south. Okay, you can see the gorgeous view from La Silla Observatory. We are at 2,600 meters above the sea. And in this point, from this point, and in July 2nd, 2019, we have 1,000 people looking to the sky, looking to the sun, because was the total eclipse of July 2nd, 2019. Was a magnum event of 1,000 people at La Silla Observatory. Even the president of Chile was here with us, looking to the eclipse. Okay, but let's go to the inside of the 3.6. Here we are. All right, perfect. This is the 3.6 telescope. Okay, you can see the dome. Okay, it's a really huge dome, big, from the floor to the upper part of the dome is about 20 meters. You can see a man over there. Maybe we can show this man who is there. Right there is the man. Let's say 1.8 meter in high, and you can see how small it is in comparison with the telescope and the dome. Anyways, the telescope is a classical dome, it's a classical telescope with a classical mount. Also, it's a equatorial mount. The blue part of the mount is the equatorial mount, and the light blue is the telescope itself. All right. Well, we want to say hi to our friends here that join us. I don't know if there is any question. We want to say Frank Tesnowatsky is asking for the tour guide instruction to visit you is on my to-do list before I turn into dust. All right, Frankster. Well, we are going to be here for a long time. We are building a new telescope in Chile, so don't worry, we will have time. But remember that you have to apply for Saturdays, every Saturdays, to La Silla o Paranal at 10 o'clock in the morning or 2 p.m. in the afternoon. You can look the link for to booking online in our webpage eso.org, eso.org, and you will find the links and the online system for booking. So we will be waiting for you here, Franksters. It'll be a pleasure to have you with us. We also have a TC Savas from Turkey. Hello, hello, hello. There is no question so far, I think. Do you have any question, Felipe? Or any comment?
Remember, all people to see us. You can leave your questions, readings, whenever you want to know about the astronomy, the telescope show us on everything you want to know about astronomy. Nan and I is prepared to answer any question except for except for ETs, but you can leave or you want to know in the possible can answer you. So I have a popular question about the telescope. Is how far can see the telescope? How far can see? Or
Yes. Go ahead. Can you answer it yourself, please?
the telescope have a different resolutions because the telescope is similar to a camera, a little camera you have in the cell phone or in a professional cams. Have a resolution to see the pictures. So the the telescope is in the same logic. I need to see the stars in the far distance. So I need more resolution to see in better quality. So different telescopes have a different resolution to see different part of the stars, of nebulas, or galaxies. We need a different resolution to see different different parts of definition of the picture can take with one telescope. And I have another question. Snowy say, are you able to watch any Are you able to watch any exoplanet up close? To watch
Well, it's a very good
exoplanet?
question. It's a very
Yes,
good
that's
question because we are in a telescope. What we're looking now is a 3.6-meter telescope, and this telescope is specialized in looking for planets around other stars. Actually, this telescope, the 3.6, was part of a different telescope that found the nearest exosolar planets, which is in Alpha Centauris, in Proxima Centauris B. That is the most close um, exoplanet ever found. Well, is the closest star to us, anyways. Well, if how we watch the exoplanets? Well, we don't watch them directly, not yet. Okay, what we do there, you have a video where you have a planet around a star, and what that the star does is to pull the star a little bit because gravity, like for example, the moon push or pull our planet. Same thing does a planet around a star. The planet will pull the star. What we can see is how much that planet pulled the star. How so what we see is how the star, not the planet, we see the star, how the star get close or far away from us. A little bit, just a little bit. We can measure that difference, what we call radio velocity, through the spectrum and through the Doppler effect. Okay, I won't go in that, which could be a little bit technical. And then what we can do is know what kind of planet we have. For example, if the planet is very big, this planet will pull more the star. And if the planet is smaller, will pull it less. Okay. And also the distance, and we can know everything, but we cannot see the planet directly. What we do, we say we detect, that's the word that we use. We detect the planet around the stars. With this technique and another techniques around the world, observatories has found about more than 5,000 planets already around other stars beside our own sun. And anyways, the ELT, the extremely large telescope, are going to be able to see a planet. We look direct to the planet, but we have to wait for the ELT to be ready. Okay. Well, we say hi also to Jose Maria, who is again with us. Thank you for your greetings to La Silla team. We will continue. Well, let's see how a telescope works. A telescope work. We have to go inside the telescope again, please. There we go. Well, first of all, we have to open a window. Okay, we have to open, as you see here in the in your screen. There is an opening. Okay, a window that we open, so we let the light to go inside. Of course, this picture is a daytime picture, but we take in the night. Everything is dark, no light is allowed, and the light of the star will go inside and will go to the main mirror. In this case, the main mirror is right where Felipe is showing now, right there. The mirror is very special. It's first, it's 3.6 mirror in diameter. It's a little curve, okay, and has an aluminum layer. So the light will go there, will be reflected in that mirror, and then will go back up to the secondary mirror in that black tube. Inside there is another mirror, a secondary mirror, okay, which is convex, the other way around. And then the light will go back again. Oh, here we have a very nice picture from the top of the telescope. There is where the mirror, the secondary mirror is. The light goes back, goes through that little hole. Well, that black thing is open, so the light goes straight to the main mirror, to the center of the main mirror, and from there the light goes to that cage. In that cage, behind the mirror, that cage is behind the mirror, is the instrument. Actually, today we don't have instrument. What we do have there are um, the fiber optic. The fiber optic will get that information and will send it to a very special instrument called HARPS, which detects planets around other stars. It's a very sensitive instrument, okay, a spectrograph. A spectrograph means that we take the light and we analyze the light, okay, not to find, as you saw in the mirror before, if there is a planet around another star or not. So that instrument is in the third floor in this building, and we send information from here, from the telescope, from that case behind the mirror, underneath the mirror, to the room where in the third floor where is HARP. And from there, the information goes to the computer room where the astronomers sit in the night. The astronomers do not come in the night, not anymore. 30 years ago, there was a control room inside of the telescope, and there was machine, there was computers, but all that create heat. And the problem with heat is that if you in the day is we have to keep the dome closed, so the heat accumulate inside of the dome. And in the night, when you open the dome, that heat will go outside and will produce turbulence around the dome. And that turbulence is very bad for astronomers because the light which is coming from the star, traveling for thousands of years in the empty space, have to go through our atmosphere. And if our atmosphere is with turbulence, it has turbulence, then we will have not a very good image. That's why we avoid any turbulence. And that's why we are in Atacama Desert, because in the Atacama Desert it's so dry, there is a little bit of water in the atmosphere, so we do not have too much turbulence. And that's why we have the best sky around the world. All right. I don't know if there is any more question. Any other comment, Felipe, that you want to add for before we go to the next telescope?
We need a better telescope to see the better part of the sky. This is a old telescope, but how is the new telescope? What what is the form of the new telescope? We have a one in La Silla.
Excuse me. This
Sorry for my connection. What is the next? What is the next telescope? Can I see? What is the next telescope?
the NTT. But there is a question. Does the climate change affect your
Ah,
work? I think no, it hasn't.
does does the climate change affect your works? And that's right. the the weathers can affect the work of the astronomers, or the telescope affect the efficiency of the telescope, because it's not the same in a shiny day, in a shiny nights, because the moon, or raining, or the clouds around La Silla is not the same. Affect too much the wind speed, humidity, or the the heat of the ambient in general is affect every part of the observation, so affect too much.
Yes, it does,
So
but we don't have too much change. I mean, usually we have clear night per year. Okay, thanks to what we call the inversion in the ocean. In the ocean, we have what we call the Humboldt stream, which is a cold current from the Antarctica, and that produce here we will see it a little bit. We're looking to the ocean now, to the Pacific Ocean, and always the ocean, the Pacific Ocean is cloudy, it's under cloud because this Humboldt current, Humboldt current, produce that the clouds do not go up over the 1,000 meters. So we're at 2,600 meters above the sea. So most of the time, it's a perfect night. Well, in this case, we're looking some zeros in the sky with this picture, but usually we have, as I told you, 300 clear night per year. All right, I think it's time to go to the next telescope, which is the NTT, the New Technology Telescope. Well, the name of this telescope uh, talk for itself. The entity means new technology telescope. Why? Because we have new technology telescope. With new technology, first thing we can see is that the building is totally different. Okay, we open the whole building. It's like to divide the building in two parts in order to open the whole building. Okay, that is very good for us because it helps us to equalize temperature. In the night, in the sunset, we open the building so the wind can go inside, will cross the whole building, and will equalize temperature inside and outside. That's very good because when we do that, we don't produce any turbulence around the dome because change of temperature in the atmosphere. That's why we do that, and that's why we call that something new. It's a new way to build telescope, and that's why we call new technology telescope. But also we have the mirror is very special. Okay, the mirror, as you can see, we will get close to the mirror, is made of cerudur. This is a prototype mirror. All the mirrors today are built of cerudur. Cerudur is a low expansion ceramic that allowed us to build a one-piece mirror of 8.2 meter in diameter. For example, the mirror from Paranal are 8.2. There are four mirror of 8.2 meter diameter each. In this case, the NTT is 3.58. As you see, the mirror in diameter is almost the same that the mirror of the 3.6. It's only 2 centimeter shorter, smaller than the 3.6 mirror. However, this because this type of ceramic, yes, the cerudur, allows us to build this new and smaller dome and a smaller also telescope, or let's say better the mount. Okay, in this case we don't have an equatorial mount. In this case we have an alt azimuth mount. That means that the whole building rotate in 360 degrees. That means when in the night we will we will point the telescope to the star, and then we will follow. When we follow the star, the whole building will rotate in 360 degrees. Okay, How does the telescope work? Well, it works same like the 3.6. Okay, there we're looking to the 3.6. It's very different, as you remember. In the night, when we move the telescope, the whole building will rotate in 360 degrees. And but the way that the mirror or the telescope capture the light is the same. Let's talk about this. You have first the light will go to the main mirror. Okay, it's also this 3.58 centimeter in diameter, has this aluminum layer in the surface. The light will be reflected in the mirror. From the mirror will be reflected to the secondary mirror, as same like it happened at the 3.6. But now when the light goes back down, yes, we want to have a third mirror right there. You cannot see it in this picture, but it's a third mirror in 45 degrees. That mirror will send the light to the right, or we can change that 45 mirror, flat mirror, and we can point the light, send the light to the left. We can send then the light to the right or to the left. We have to choose which one, where we wanted to send it. But why we do that? Because the instrument, okay, the instrument are in another room close to the telescope. You see the door over there. If you go through the door, you will be in the instrument. The instrument in this case, we can have different instrument. We can have a, for example, visible instrument. That means that we can take pictures, and also do spectrography, analyze the light. As I told you before, in the case of the 3.6, we can detect planets around other stars with a special instrument. But with other instrument, the astronomer, what do they take the light, they analyze the light, and that light tell us everything about the star. Will tell us how old is the star, or how young it is the star, it have planets around, etc., etc. In this case, we have two instruments, one to the right, another to the left. So the astronomer then I will have to decide if he's going to use the instrument at the right, or if he's going to use the instrument at the left. What is the difference between the instrument? There's the door where you go to the other instrument. What's the difference? The difference will depend on the instrument. Usually, we have a visible instrument, and also we have an infrared instrument. Infrared instrument means that the instrument will detect the heat of the object. There is some object in the sky, galaxies or especially clouds, that do not send light, or do not send only light, visible light, but they are sending this heat. Heat is the infrared, so we can detect that infrared and also analyze the object, and will tell us a lot of about it. Well, all this is done not from here. Remember, the astronomers do not work in the telescope anymore. They work in the control room. Okay, the control room in the case of La Silla is about 1 kilometer from here. Here we are. We're looking at video in the night of the control room. To your right, you have the 3.6 control room, and to the left, you have the NTT control room. Of course, as you see, the windows in the back part are all closed because no light can go outside in the night. Um, Usually, in the control room, you will have the astronomer, and also you will have the operator, the one who drive the telescope, the one who fly the telescope to everywhere in the universe. Maybe Felipe can tell us a little bit more about the control room and what they do in the control room.
And the first part for astronomer comes to the control room, and the first part is 1 year pass. In a 1 year pass ago, the astronomer prepared the research and 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 write a proposal or research proposal, and send to the ESO. The astronomer can take can can I say, um, reserve a one telescope to use, can use the Paranal or the Silla. The astronomer need a particular telescope. So in 1 year's past can write a proposal, sent to the ESO. The ESO in Germany see the different proposal and give to the astronomer a nights per year, around 2 or 3 a nights average per years can use the telescope. But so the ESO inform to the astronomer, and astronomer come to for example, to La Silla. So here we are in La Silla control room. We have two different peoples. The first one is the color clouds peoples. Is the astronomer itself. The astronomer come and use the telescopes and take the data, and then leaves and research in our university, in scientist labs. And the other part of the control room is the darker clouds people. This is the a controller, the telescope controllers. The telescope controller can move the telescope right, left, up, down, wherever the astronomer wants. The astronomer wants to see 3 stars, and the control and the controller prepared the telescope to see the 3 stars. So this is the mechanic to use the telescope around 1 years to come La Silla. It's a how I see, it's a little similar to bingo, to the competition of all nights of the years. And then we have a 300 nights, clear nights per year. That's right, around.
Right,
So
right.
300 nights, the astronomer fight with one other to use all night, but not always is the same. Some astronomer we needed to 1 p.m. to 1 a.m. to 3 a.m., and the other astronomer needed 3 a.m. and to 5 a.m. So it's different, different times. So the astronomer can use together the same telescope in different time. So that is the control room. Is too complex and too simply in the way to see.
All right. I think it was a great explanation. Thank you, Felipe. And now I think that something that everybody wants to know is what the astronomer had discovered already with ESO telescope. So we have prepared a special a
A
video
video.
for to tell you about it.
So
Let's go
this is
with the
the
video, please.
Observations with ESO telescopes have led to many breakthroughs in astronomy and, over the years, have been responsible for some truly remarkable findings. Here is our list of ESO's top 10 astronomical discoveries so far. Astronomers using ESO's Very Large Telescope have discovered by far the brightest galaxy yet found in the early universe, and found strong evidence that examples of the first generation of stars lurk within it, stars that were previously only theoretical. These massive, brilliant objects were the creators of the first heavy elements in history, elements that are necessary to forge the stars we see around us today, the planets that orbit them, and life as we know it. ESO telescopes have provided definitive proof that long gamma-ray bursts are linked with the climatic explosions of massive stars, therefore solving an enduring mystery. A telescope at La Silla was also able to observe the visible light from a short gamma-ray burst for the first time, showing that this family of objects most likely originates from colliding neutron stars. Astronomers using ESO's HARPS instrument in 2010 discovered a planetary system containing at least 5 planets orbiting the Sun-like star HD 10180. They also found evidence that two other planets may be present, one of which, if confirmed, would be among the lowest mass exoplanets ever found. Newer observations and reanalysis of the data suggest that there could be even more planets around this star. ESO's Very Large Telescope was used to detect carbon monoxide molecules in a remote galaxy, seen as it was 11 billion years ago, a feat that had remained elusive for 25 years. This allowed astronomers to obtain the most precise measurement of the cosmic temperature at such a remote epoch, and it matched the temperature predicted by the Big Bang Theory. The atmosphere around a super-Earth exoplanet was analysed for the first time using the VLT. The planet, which is known as GJ1214b, was studied as it passed in front of its parent star, and some of the starlight filtered through the planet's atmosphere. The atmosphere was found to be either mostly water in the form of steam or dominated by thick clouds or haze. Using ESO's VLT, astronomers measured the age of the oldest star known in the Milky Way. At 13.2 billion years old, the star was born in the earliest era of star formation in the universe. Uranium was also detected in a Milky Way star and used as an independent estimate of the age of the galaxy. The VLT obtained the first ever image of a planet outside our solar system. The planet, which has a mass about 5 times that of Jupiter, orbits a failed star, a brown dwarf, at a distance of 55 times the average distance between the Earth and the Sun. In 2014, ALMA, the Atacama Large Millimeter Submillimeter Array, revealed remarkable details of a solar system that is forming. The images of HL Tauri were the sharpest ever made at sub-millimeter wavelengths. They show how forming planets are vacuuming up dust and gas in a protoplanetary disk. One of ESO's proudest moments came when 2 independent research teams, including ESO staff, arrived at a truly revolutionary finding: that the cosmos is not only expanding, but that it is doing so at an increasing rate. The findings of the separate teams were based on observations of exploding stars, or supernovae, including measurements made from ESO's telescopes at La Silla and Paranal. This discovery was rewarded with the 2011 Nobel Prize in Physics. And finally, several of ESO's flagship telescopes were used in a 20-year study to obtain the most detailed view ever of the surroundings of the monster lurking at the heart of our galaxy, a supermassive black hole. Astronomy is always moving forwards, and ESO's top 10 scientific discoveries are not set in stone.
Hello, welcome back. Well, that was astonished those discoveries from ESO telescopes, but now we want to invite you a very special view of the universe, of the sky, from La Silla telescope. Here with this app, which is the 360 degrees um, virtual tour, we can go to the sky. Actually, there we go. We can see the Milky Way. Of course, if you come to Chile, our visit at the observatory are until 5 p.m. After 5 p.m., nobody can be in the observatory, but you will be able to see this gorgeous sky anyways, because you just go to the Atacama Desert and you will have this sky. So we encourage invite you to come down to Chile and enjoy this this amazing tour, this amazing sky. Let's talk a little bit about the sky. Let's see if here we go. We can see Orion, the Orion constellation, which those that are from the northern sky, from the northern hemisphere, you are very used to it. We can see there the what we call the Orion belt, the three stars. But actually, the three star in Latin America, we call it the three Marys or las tres Marías. And also, we can one of the objects very important in the Orion constellation is the Orion Nebula, where thousand maybe we can do a close up to the nebula. There we go. That's the nebula. You can see with small telescope you are able to see it. Even with some good binoculars you will be able to see it. You can see the naked eye but no detail of it. And this nebula is important because there is thousands of stars born. It's a real this is where the stars are born. And we go a little up, we will see the Sirio star, one of the brightest star in the sky, part of the big dog constellation. There we go. Those are very well known from the northern sky. However, if we go a little south in this sky, we will go southern part of the sky. I'm sure not many of you are used to see this sky. First of all, we are looking these two clouds over there. Okay, in the southern sky, we are already looking direct to the south. And the southern sky, these two clouds are the Magallanes clouds. They are no clouds of atmospheric cloud. They are not atmospheric cloud. They are galaxies. Actually, Magallanes, the one who discovered them about 500 years ago when he was navigating in the southern seas, he saw this cloud and he called them clouds. That's why we call it Magallanes Cloud. However, these clouds are galaxies, are satellite galaxies of our own galaxy. They are not. These two objects. They're the object, the only object that we can see naked eye that they are not part of our galaxy. They're this satellite galaxy, and we can use them for find the south. We can use them as a reference in order to be guided in the southern hemisphere. In the northern hemisphere, you have the star, the polar star. You look to the polar star and you know where the north is. In the southern hemisphere, we don't have any southern polar star. We have the Magallanes cloud. If you take the Magallanes cloud and you make a triangle, as Felipe is showing there, the angles where there's nothing, the angle there you have the southern celestial pole. What is the southern celestial pole? Is the point where all the stars are rotating, okay, in the night, okay? Because, well, you know that the sky doesn't rotate. What we do rotate, but looks like that the sky rotates in the night. And also, we have the Southern Cross. Just in front of the Magallanes cloud, we can find the Southern Cross, okay? And the Southern Cross also is pointing to the south. Okay, so the Southern Cross has a long stick and a short stick. If you take the long stick is pointing to the southern hemisphere and the southern celestial pole. You just have to uh, make it longer 3.5 times, and you will see 1, 2, 3.5, and then you are in the same point that we found before with the Magallanes cloud, the southern celestial pole. Okay, so easy. You won't get lost if you come down to the Atacama Desert, and if you get the chance to see this video. However, in the southern hemisphere, in Latin America, we also have a very good astronomer 2,000 years ago with our people, our inhabitants, the culture before the Spanish came. They also were great astronomers and they have this gorgeous sky, and especially they have no light pollution, so they could see very bright the sky. This brightness that you see now is the Milky Way, and against this brightness we can see this dark spot. And from this dark spot, they also made their own constellation. Here we can see easily the Llama constellation. Okay, it looks like a llama. It's a dark spot. Maybe Felipe can show us. There we go. See, you can see the head of the llama, the body of the llama, the legs of the llama, and of course the eye of the llama, which is Alpha Centaurus. Alpha Centauri is that bright star, the closest star to us, and it's the light, is the eye of the llama. Okay, close to the llama constellation, up close to the Southern Cross, we have the Bird constellation, and so on. The good thing is because they could see all this dark spot in the Milky Way. What are these dark spot in the Milky Way? Are clouds of gas and dust that doesn't let the light that is behind go through it. That's why we see it very dark. I don't know if you want to add anything else before we go back to La Silla Observatory, Felipe.
We have a question about is there a month or time of the year that is better for La Silla for me to visit? Winter or summer?
Well,
A better month?
well, depends. In our winter, that means from let's say April to May, June, July, there's less people coming in, so will be not so crowded. But in order about the sky, we have better sky. I think better sky in winter, our winter, because if you want to come to La Silla, you can come every Saturday. Will be during the day because we don't have tours at night. The last tour end at 5 p.m. But you will be able to stay in the desert and look to the sky. And in the winter time, in the southern sky, the Milky Way is better be is better, you can see it better. So if you're interested in doing pictures or enjoy the Milky Way, it's better to come in our winter, but you have to come with clothes. It's not cloudy. Most of the time, it's not cloudy, but it's very cold, especially in the desert. Okay, that will be my suggestion.
So this is a one question. We have a more question, but we need to go to the hotel
Oh,
because
we have 5 minutes to
we have
finish.
to finish. So we answered the last questions. Interesting last question have. So there is the hotel where the
Yeah,
people
well, we
rest.
have La Silla is in a small city, a small technological city, and this is a place where to rest, where to sleep, eat, and of course, our friend here is taking a coffee. He's the one who took the pictures. Let you know that this visit or this virtual visit, virtual tour is in our webpage. Visit please our webpage, eso.org. It has a different language. You can go there and have all these pictures. I don't know, we show like only 10 pictures, but we have thousands of pictures in our webpage in different resolution, videos also. There you have the Milky Way. It's a gorgeous Milky Way again, and you can download them for free. And we have, as I said, videos, post, and also news. Every time that a new event or a new discovery is made by the ESO telescope, we have it in our webpage. Also, we have, of course, our social media, the social media in Facebook. You can find us in also in YouTube. So please keep us in touch. We always send in news and let you know also how to visit us, and also how to join another of this tour, this virtual tour, because we also have a virtual tour for Paranal in English and Spanish every Saturday. This Saturday was La Silla in English. Next Saturday, we're going to have I think it's Paranal, but you can find out um, in our social media, in Facebook or YouTube. Please follow us, and we were so pleased to have you with us. Hopefully, you enjoyed this visit, and I will let you with Felipe to say goodbye.
Thank you. Sorry for not answer the last question. In the next week, can answers the question you have. Remember, every Saturday have a virtual guy. I'm here every Saturday too. So thank you for the question, for your readings, and see you soon, to everyone. So that is goodbye, everyone.
Goodbye. Thank you. Bye bye.